Based on the graphing grid that we see here, we got time on the horizontal, distance on the vertical. If we have some graph on here, and we don't even know what the graph is doing, might be some curve like that, might be straight, who knows? What would the slope of that graph actually represent? Speed. Otherwise known as what? Velocity, yes. Now, a little detail here. I need to get a little technical on you. And this is a technicality that we're going to worry about later. For now, it's not actually a big deal, but I want to kind of give you that preview. Okay. Speed and velocity are actually different things. Speed is basically the absolute value of velocity. So velocity can be positive or negative. So you can have a positive forward velocity, or you can have a negative and therefore backward velocity. Speed is always positive. If you're going backwards, your speed is just however quickly you're going backwards, and it's always going to be positive. So it's a little detail that it's not going to be a big deal now, but it is going to be a big deal later. For our purposes today and where we're heading with this, because distance can go down and we want to differentiate between that, we're going to stick with the velocity term for that reason. All right. So looking at this graph then, when was this runner, because yes, this is just a graph of a runner, when was this runner moving the fastest? It looks like it's right at one of the numbers, doesn't it?
I think it's at...
It looks to me like it's right at 20. Now, what are we looking for? It's not how high the curve is, because that represents distance. It's its steepness, that is, its slope. And so we're looking at the slope to know when the runner is actually moving the fastest. Now the slope, though, remember, here the slope is at a specific point. We want to know what point in time he's going the fastest. That point and his velocity at that point is called the runner's instantaneous velocity. Instantaneous, notice the root word of that, instant. So it's what is the velocity at a specific instant rather than over a long time. Now, because these terms are going to come back over time here, these need to go into your notes. Instantaneous velocity versus average velocity. And leave yourself a little bit of room because I'm going to add a little bit after we go through a few more pieces as well. And yes, for those of you who have taken or are taking physics, this is going to be familiar information here as well. In fact, you're going to notice a lot of overlap between concepts from physics and calculus. Actually, they help each one understand the other. So it's going to be a nice parallel for those of you who are in that kind of a situation. Now, to help understand each of these and what makes them different. So, instantaneous velocity first. So, this is a nice way to remember instantaneous velocity. You know, as you're driving down the road and the police officer is there with the speed gun is giving a reading of how fast you're going at that moment. Now, we could get into debates about whether that's really instantaneous or just a very, very small average velocity. But for our purposes here of understanding what's going on, this is giving us an instantaneous velocity here. And so it's telling us how fast is it going at that specific moment. Now, alternatively, what would average velocity look if you were trying to check this sort of thing? It's actually something that's used in different parts of the country. We don't see this much here. But they actually set up average speed cameras as a way to be able to catch speeders as well, where they'll set up a camera at one end, and then they'll just see how long does it take you to get to the next camera, and if it takes you too little time, then you obviously were speeding, and they can calculate how fast you're going between them. They calculate your average velocity between those 2 points. And so that's just another way to understand what average velocity is actually doing there. Now, in terms of the mathematics, which of course is what we're going to be dealing with in here, we can see both of these on graphs as well. So take a look at both of these graphs, please. One of these graphs represents instantaneous velocity, and one of these graphs represents average velocity. Can you tell which one is which based on what you're seeing here? Perfect, yeah, that one on the left is the average velocity. The average velocity is the velocity between the 2 points rather than just at the 1 point. So notice then the connection to what we were doing earlier this week, where average velocity then is figured out by finding the secant line, the slope of the secant line. And the tangent line, that one that just touches at one point, the tangent line then is the instantaneous velocity. And so this is the addition that I'm having you put in with the notes that you took earlier. So add each of those two facts to their definitions, please.